So the electric potential essentially describes what would happen if we were to put a point charge into an electric field. It is the work that will be done by the electric field on moving that point charge from, let's say, infinity to some other point. And also, the work that will be done is independent of the path that will be taken. So we could go from between 2 points, a point A and a point B, along either path 1 or along path 2. Okay, so the line integral is path independent. And since the line integral is path independent, what this means is we can write our electric potential, which is VR, equal to minus the gradient from some reference point, which we're going to call O, to some point R of E dot dl. And we should have a prime up here since we're talking about the source. The negative sign essentially tells us that the electric field is pointing in the direction of decrease for V. So that's our electric potential. Now what is the potential difference between our 2 points A and B? So we can write this as V of B minus V of A be equal to minus the integral from our reference point 0 to B of E dot dl minus integral from 0 to A of E dot dl. So now that we have this, what we can do is we can write it out a little bit neater. So what we have here is the integral of minus between A and B of E dot dl. Okay, so following on from this, what we can then write is our fundamental theorem for gradients. So the fundamental theorem for gradients tells us that the value of the function at the boundary, so V minus VA, is equal to, in this case, the line integral between A and B of the gradient in our potential V. So now what we can do is you can write the right hand side here of this, so it's between A and B integral of gradient of V dot dl is equal to minus the integral between A and B of E dot dl. Okay, now since this is going to be true for any point A and B, what it means is that the integrands must be equal. Now, since the integrands are equal, we can write our electric field E in terms of the gradient of some scalar potential V. Okay, so this is a key result.